Okay, what we're going to do is implement this class diagram, extending what we had done before. So let's start with instrument. So instrument, where is it? Okay, we're going to start with the instrument class. If you remember, this was declared just kind of regularly as before, and it just had the tune method and a getter for that. So what we're going to do is we're going to add an abstract method. So public abstract void play note. Oops, nota note. All right. Okay, you see that no red squiggly that or on this yet. So that's legal. Again, notice that if I leave off abstract, I get red squigglies, and it says missing method body or declare abstract. So in fact, so if I forget abstract, I get prompted for it at least. Okay. So, but now I'm getting some red squigglies up here. What does it say? It says instrument is not abstract and does not override abstract method play. So let's see what, okay, basically what it offers is says make class instrument abstract. So when we do that, it fills in abstract. As again, that's why I said NetBeans helps us out on this, because if we declare a method to be abstract, then it, okay. So now, okay, let's see what what has and hasn't gone red squiggly on us. See, notice here. Well, okay, instrument is fine, notes fine. The test. Well, notice the test doesn't give us red squigglies for this. In fact, the test doesn't seem to give us red squigglies on anything. But it shouldn't run. Let's just try running it to see. And it says, yeah, exception, and who knows what that is. Basically here, when we tried to instantiate strings, again, notice here, see the little red guys, the red exclamations? Well, see, what is it complaining about? Okay, well, let's see. It says strings is not abstract and does not override abstract method play. So remember, we declared play to be abstract in the superclass instrument, and here's a class which extends it but doesn't override it. And so we have two choices. We can actually either declare this method, this class, to be abstract. Oops, we spell it correctly. Okay, so okay, that makes the red squiggly go away for this class. But if we make strings, and there's nothing wrong with this, we can actually do that. In other words, we can kick the can down the road, or in this case, down to our subclasses. So we're saying, okay, yeah, instrument is abstract, we'll make strings abstract too. Of course, what that means is we can't instantiate it. So for this example, we do want to instantiate it. And so what do we have to do to instantiate a subclass of an abstract class that has one or more abstract methods? And let's see what, we have all kinds of suggestions. The main two at the top, we can implement all abstract methods, which is a very handy one, or we can make strings abstract, so it'll fill in the abstract for us. So let's see what happens when it says implement all abstract methods. Okay, so what it does, and again, if you're coding by the original IDE, which consisted of a plain text editor and the command prompt, then you didn't have such things here. But again, notice that, okay, one is we have this override. We've seen override before, right? We've seen override with toString, where there we were actually overriding a concrete method. Here we're overriding an abstract method. And in fact, and this is a NetBeans thing, and it's kind of a smart thing. What it does is it throws an unsupported operation exception. It says, okay, I'm going to give you the concrete implementation skeleton here, but if you try to invoke it, you're going to get an exception. But red squigglies still go away. And we can do the same thing pretty much with every one of these. And so let's do that just to kind of get going. And now, see, now all the red things have gone away, and we can actually now run our program before, because we didn't try to call anything. But let's say, so what's going to happen if we try to, okay, say we can play, and it wants us to play an E. All right, so we'll play an E. Just by the way, I added a bunch of notes to the note class. Okay. So what's going to happen when we try to play E? Well, what's going to happen? It's going to actually tune the first one, the strings, and then it's going to try to play E on the strings. But what it's going to run into is this unsupported operation exception. Again, just to see it. See, exception. Okay. See, notice that first it tuned, and then it hit the unsupported operation exception, and then again these, if I haven't pointed it out before, when you get these runtime exceptions, they give you links to see where it happened. So here's where it started. It started when we tried to play this, and here's where the actual exception happened. Now, later in the course, we'll be writing our own exceptions. So now, in order to get this to run, we need to, again, normally, like I said, we're putting print line statements in this. This is only for examples. Like when you write classes, components, like your cards and the dealer and all the other stuff I have you do, never put print lines in those. This is only for pedagogical purposes, for teaching purposes. Print lines should generally only be like in main methods and things like that. There's a harangue I have about that, given the time.
So, how do you recommend troubleshooting? So, you guys base off of JavaScript and the slang that we're doing on keyboard, to be the best thing, the easiest thing for us to do is pop the log whenever we hit a bug. Is that
What's more effective here is to use the debugger, which the NetBeans debugger, which I actually used once, but didn't sort of talk about it. I'll talk to that. Actually, maybe given this, okay, here's how to use the debugger. If you click on, there are two ways to do. You've used debuggers before?
We use console log, and then we use the step thing.
Yeah.
Within our browser.
Yeah. So doing printing to the console is the absolute worst way to debug anything. Okay. Well, here's what's bad about it. I'm going to pause this. Here's how we could identify this with the debugger. So let's. So in this case, what's happened was we can actually kind of go from here was a problem. So when I click on these on the line numbers, it writes it in, I don't know what that color is, and here's again, like I'm pretending I don't know exactly why this did this. I mean, it's obvious from looking at it, but let's say I don't know. All right, so now instead of right-clicking and saying run, I right-click and say debug. And what it's going to do is it's going to run to the breakpoint. So see where it's green? And then I see, and unfortunately I can't make it bigger, but it shows me the variables. So here's the instruments array. Sassy strings, so it gives me the class of those. And in this case, where I am, instrument. In fact, when I hover on here, you can see that it shows there, and it also shows down here. I also have the call stack, which in this case is just right here. So now even if I haven't hit a breakpoint, now if I want to run to say, okay, everything looks fine here, there's been no error yet, so I want to run to the next breakpoint. So I hit this green arrow up here, and that takes me to the next breakpoint. Okay, so I see this.
So that would jump through back and forth to the different programs where we set the breakpoints.
Yeah, wherever you set the breakpoint, if you run, and furthermore, what I could over here, like there's like this little panel appears. I can step over. So I can step into, and I can step out of. So in this case, if I just want to step over, and all of a sudden, boom, and I step over, and then here, this is deep in Java where that exception got thrown. And if I want to step out of that, then I step out, and then I'm actually done in this case, because the panel disappears. So this is, if you want to see how stuff is going, you can actually sort of step through things like that. And also, let's set a breakpoint right here. And I can literally step through. Okay, so here, so at this point, all I have is my args. I step over it. Now I have instruments, and they're all null. I step over. Now strings has been instantiated. Now brass. Now the flat wind, French horn. And then now I'm down here. So in fact, even if I hadn't set this breakpoint, I can go and say, okay, now, all right, everything's working fine in here. It must be inside this method. And so if I hit this step into, it goes into the method call. All right, and then, all right, so that looks okay. If I step over, I can step out. All right, so now, so the problem wasn't there. So let's step into this. So I step into this, and then I can either, again, just by saying, okay, here's what note am I trying to play? What is this about? And I mean, in this case, I can actually see, again, when I try to step over it, I see that there was an exception. Why was there an exception? And I can stop the whole thing by just sort of seeing here. I look at this line, I see what the problem is. So that's a better way to debug than the console thing, because now I mean, all I need to do is, if I want to just run the program, now of course I run them, I get the same results, but I haven't edited, you know, these breakpoints don't actually edit the code. I haven't changed a line of the code. These breakpoints are kind of external to the code. And if I can sort of see all the breakpoints that I have here, and then I can actually delete them all if I make them go away. Okay, so we're here. All right, so now, again, if we're being really taking baby steps, okay, so we see strings playing, and then we have another exception. And then Now, I mean, in this particular case, if I do this normally, what I do is that when I generate them, then I'll implement it there. But if I forget, then this will gently remind me. And what I would normally be doing here is actually implementing this abstract method. And okay, so now this should be the last problem. Okay. So now here's the thing. Now notice that in this code here, again, we have defined an array of instruments. So, and now notice this. We can instantiate an array of an abstract class because the array of the abstract class is actually concrete. An array, that sounds weird. An array of abstract classes is concrete. The array is concrete. Now, I cannot instantiate an instrument, though. If I were to try, let's try to see. I can actually try. Oops, yeah, see. And NetBeans kind of over helps here. So what it does, so again, if I try to do that, instrument is abstract, cannot be instantiated. So it says And if you're not careful, this is something I don't like about NetBeans, is that what it tried to do is it actually tried to make it a concrete class by kind of on the fly adding the method. Show you where it's trying to. See if it says, it kind of will tend to do that. And then again, it's complaining about the, see what it's done is, this is something that you generally, I do not recommend. It's something, for whatever reason, they added to Java a number of versions ago. You can basically kind of override things on the fly, kind of anonymously. Terrible idea, in my opinion, but that's just me. All right, so I'm going to comment this out. Okay, so again, even though instrument is abstract, even if the array were abstract, we could still declare it to be that type, but the array of instruments, the array of an abstract class is still concrete. Now here, again, all the compiler knows is that these are instruments, and then this is all happening at runtime. And see, just because this, for example, this method gets called, there's no guarantee that somewhere later in the code, or maybe even in some other method, some other class that uses this array, that be set to something else. So at compile time, you don't know what the particular instance is. Now, what you do know is that because each of these are an instrument, because strings overrides instrument, it is an instrument. Brass is an instrument. B flat wind is an instrument. They are guaranteed to have the play method. They are guaranteed, in fact, to have all the methods which are declared in there, either via inheritance, overriding, or adding, or whatever. Everything in instruments has to be in those other ones. So when we execute these, it's not until runtime that these methods are actually invoked. Now, the tune method, remember, we implemented up in the instrument class, so there's no ambiguity about where that gets called. But the play method, there's a different one for each class. And we see that it does the right thing. So when it calls play on the strings, it executes the strings code. When it calls play on the brass, it executes the brass code. See, so this is an example of how late binding works. Because again, at compile time, there's no way of knowing which play is going to be implemented, which executed. But it has to find it. And it finds it at runtime by saying, all right, instrument, what type are you? So even though you're, well, I'm not, wait, I misspoke. The instrument is actually declared to be, in this case, a type of instrument. But what actual object are you? What actual class are you from? So if you're a strings, then when you get to this play, remember what the Java Virtual Machine does. It says play, all right, I'm looking for a play method with a signature note on the strings, on an instance of strings. And so, do I have one? And the answer is yes. I have one, so I implement it. Likewise, when it goes to the next one, I'm implementing play on an instance of brass. So I look for play in brass, and there it is. However, the tune method, so let's go back to strings. It says, okay, on strings, invoke tune. I look at strings, there's no tune. So let's look in at superclass. Superclass, there's the tune. So it implements that. So, and no matter how deep the hierarchy, that's how it does business. It looks for the method in the actual instance, and if it doesn't find it, it goes to the superclass. And if it doesn't find there, it goes to the superclass there. And it keeps going until it hits object. And it's guaranteed to find it because otherwise the compiler wouldn't let it run. Make sense? Sort of. I see a questioning look or two. And I know I've actually sort of said things like this before, but it really bears repeating and understanding about how how the program is doing what it's doing. Because as you've no doubt noticed, or if you haven't, then you will soon. Most of the programming time is spent debugging, figuring out why the heck this thing is doing what it's doing. And as I've said before, programs are really stupid because they do what you tell them to and not what you want them to. Right? And until such time as artificial intelligence gives us the ability to write programs that do what we want them to without us having to actually tell them how to do it, then we're going to be stuck with this.